For this lesson, we're going to continue to work with application of problems that result in systems of equations. Here we have Carol being twice Laura's age. So I'm going to use C for Carol and L for Laura. So C equals twice Laura's age. Now in 6 years, to figure out Carol's age, I would add 6. And to figure out Laura's age, I would add 6. And it says the sum of their ages is 30. So the C plus 6 is Carol's age in 6 years, and the L plus 6 is Laura's age in 6 years. Since we've solved here for L in terms of C, or excuse me, C in terms of L, I can put 2L in place of C here and do substitution. So I'm going to have 2L plus 6 plus L plus 6 equals 30. And when I combine like terms, I'll have 3L plus 12 equals 30. And then if we subtract 12 from both sides, we'd have 3L is equal to 18, which means that L is 6. And since Carol was twice as old as Laura, Carol would be 12. And we can do a quick check here to see what the sum of their ages would be 6 years from now. So in 6 years, Laura will be 12. And in 6 years, Carol will be 18. If I add 6 to 12, I get 18. I add 6 to 6, I get 12. And the sum of their ages in 6 years will be 30. Let's take a look at another example. This one is going to require us to remember that rate times time equals distance. So here we have a plane that's traveling 8,400 kilometers against the wind in 7 hours. So let's start by making a note that we have against the wind. So the time is 7 hours and the distance traveled is 8,400. I'll create a chart here. And then on the way back, the plane makes a return trip in 6 hours. And you might be wondering, how can it make that same trip of 8,400 kilometers in 6 hours? Well, that's because the plane is going with the wind, meaning that the wind is kind of helping to push the plane along. If you've ever run with the wind at your back, you know that the wind helps to push you along and make you feel like you're going faster. But if you run into the wind or against the wind, it slows you down. So going against the wind is going to take longer to go a certain distance than it would take to go with the wind. And the question here is asking for the rate of the plane in still air. In other words, what it would say the plane is going if the pilots look at the speedometer. So the rate of the plane in still air and the speed of the wind. So the plane in still air, we're going to say, is going at a rate of P. And against the wind, that's going to slow it down, so we'll say minus W. With the wind's going to speed it up, so we'll say P plus W. Now our equation is based on the fact that rate times time is equal to distance. So I'm going to get two equations here, which is good because I have two unknowns. I'm going to get my first equation by doing rate of P minus W times time, which is 7 hours, equals the distance of 8,400 kilometers. And my second equation, I'm going to get, if we're going with the wind, there the wind is helping to push the plane along. So we have rate times time equals distance. Now before we distribute and combine like terms and do that sort of thing, I'm going to actually make this equation a little simpler. I'm going to divide both sides of this equation by 7. And I'm going to divide both sides of this equation by 6. It'll actually make the equations much easier to work with. This equation here is going to be P minus W equals 1,200, And this equation over here is going to be P plus W is equal to 1,400. And at this point, you might be saying, hey, this is kind of handy because we have plus W in the one equation and minus W in the other. So that means if we add the equations together, the W's will cancel. So we have 2P equals 2,600, and dividing both sides by 2 gives us the speed of the plane of 1,300 kilometers per hour. And I know that might seem fast, but this is kilometers per hour. A kilometer is a shorter distance than a mile, so you can have a higher number here for speed. 1,300 kilometers per hour, and the wind is going to be 100 kilometers per hour. And the way we can figure that out is by realizing that the plane speed plus the wind speed is 1,400. I've already got 1,300 for the plane speed, so the wind speed would be 100 for these to add to 1,400. Let's take a look at another example involving rate, time, and distance. Here we have a motorboat, and once again we're going to have rate times time equals distance. And we have a motorboat going downstream and also going upstream. And it says that the motorboat goes 36 kilometers downstream in the same amount of time it takes to go 24 kilometers upstream. So let me put the distances in here. 36 downstream, 24 upstream, and the amount of time is the same. So I'm going to use the variable t here for time. It says to find the rate of the boat in still water. So I'm going to use the variable b. Going downstream, the boat is being pushed along by the current, and the current is 3 kilometers per hour. So I'll have b plus 3. And going upstream, the current is slowing the boat down by 3 kilometers per hour. So now I'm going to come up with my equation, rate times time equals distance. 1 for the boat going downstream, and 1 for the boat going upstream. And what I'm going to do here is I'm going to solve this equation for t. So I'm going to divide this side of the equation by b plus 3 and my right side of the equation by b plus 3. And it might not be very obvious why I'm doing this, but you'll see in a moment how this makes the problem a bit simpler. The equation on the right, I'm dividing by b minus 3 to both sides of the equation. So now my first equation is t equals 36 divided by b plus 3. And my equation on the left is t is equal to 24 over b minus 3. And if you notice, we have this expression is equal to t, but we also have this expression equal to t. So since both of the circled expressions are equal to the same thing, that means they're equal to each other. So we have 36 over b plus 3 equals 24 over b minus 3. And now we have a proportion, so I'm going to cross multiply. I'll have 36b minus 108. I'm making sure I distribute the 36. And 24b plus 72. And now I'll move the 24b over, subtracting 24b from both sides. I have 12b minus 108 equals 72. Then adding 108 to both sides, we have 12b equals 180. And dividing by 12 gives us the speed of the boat of 15 kilometers per hour. So let's substitute 15 back up top here and see what happens. If I put 15 here, I'd have the downstream rate, combined rate of 18, 15 plus 3. If I put 15 here, 15 minus 3 would give me 12. And if we do distance divided by rate, we would get the time of 2 hours going downstream. and distance divided by rate, we would get 2 hours going upstream. So we've correctly solved this equation. The rate of the boat in still water is 15 kilometers per hour.